my channel. Today we are going to dive into the fascinating world of modulation techniques used in communication systems. Specifically, we'll be exploring the differences between DSBSC and SSB modulation. So let's get started. Let's talk about DSBSC modulation, which stands for Double Sideband Suppressed Carrier. In DSBSC modulation, both the upper and lower sidebands are transmitted while the carrier is suppressed or removed entirely. This technique is achieved by multiplying the message signal with a carrier signal, generating two sidebands containing the same information. However, DSBSC requires a larger bandwidth compared to other modulation techniques. DSBSC modulation finds its primary application in broadcast radio systems. When you turn on your radio to listen to your favorite music or talk show, DSBSC modulation is commonly used to transmit audio signals. The carrier is suppressed to conserve power, and both sidebands are transmitted to ensure the faithful reproduction of the audio signal. But here's the catch: a significant portion of transmission power is wasted in transmitting the suppressed carrier, limiting the efficiency of DSBSC modulation in this context. Let's move on to SSB modulation, which stands for single sideband. SSB is a different approach to amplitude modulation where only one sideband is transmitted, while the carrier and the other sideband are suppressed or removed entirely. This technique uses complex filtering to eliminate one sideband and the carrier, resulting in a more efficient use of power and bandwidth. One of the key advantages of SSB modulation is its reduced bandwidth requirement, making it significantly more spectrum efficient than DSBSC. This makes SSB modulation particularly suitable for long distance communication systems like high frequency radio. In high frequency communication, signal can propagate over long distances by reflecting off the ionosphere. SSB modulation allows for efficient transmission over these long distances with reduced power requirement and better signal to noise ratio. SSB modulation also plays a crucial role in amateur radio. Many enthusiasts around the world enjoy engaging in voice communication using amateur radio. In this domain, SSB modulation allows for better utilization of available frequency bands, especially in situations where bandwidth is limited. Amateur radio operators often communicate over long distances using low power, and SSB modulation helps maximize the effectiveness of their transmission. Additionally, SSB modulation finds applications in military communications. Military organizations require efficient and secure communication systems, and SSB modulation offers just that. Its spectral efficiency and improved resistance to interference and noise makes it ideal for military applications. By conserving power, reducing bandwidth requirements, and enhancing signal robustness, SSB modulation ensures effective and reliable communication in challenging environments. In summary, DSBSC modulation transmits both sidebands while suppressing the carrier, providing good audio fidelity. However, it comes at the cost of increased bandwidth usage. On the other hand, SSB modulation transmits only one sideband and eliminates the carrier, resulting in improved power efficiency and reduced bandwidth requirements. This makes it suitable for long distance communication, amateur radio, and military applications. There you have it, the differences between DSBSC and